Okay, now this section, once again, you are welcome to this section. If you miss anything, please always go to the link and go to the previous videos. Welcome once again to Edu blog. Like, share, subscribe. If you have any question, leave it in the comment section below. Always remember to click on the notification bell. Okay, so under this particular section now, we are dealing with more than two vectors. It is possible. In a real life scenario, most times, what is acting at a particular object or substance is more than two. Now, what do you do in that case? How do you get the resultant vector? Let's say we have a particle. This is a particle. And we have so many forces acting on this particle. We have this force. Let's call it F1 with a direction, θ1. Watch the direction very clearly. It is the one it's making with the horizontal line. We have another force, F2, making a direction, θ2. We have another force, F3, making a direction, θ3. We have another force, F4, making a direction, θ4. It can be so many forces. I can decide to even include another one here, F5, or let's just make use of this 4. If you watch very well this diagram, we're making use of 4 forces. So what you need to do here is you have to take note of your Cartesian plane. Very, very important. Now the Cartesian plane here, let me put it down here. Here we have plus for cos, plus for sine, plus for tan. We say all of these trigonometric functions are all positive. Over to this place, only sine is positive, cos and tan negative. Therefore, always represent this quadrant with S. This place, only tan is positive, cos negative, sine negative. Therefore, here is represented with letter T, telling you that only tan is positive. In this quadrant, which is the last quadrant, only cos is positive, tan is negative, and sine is negative, so you represent that with C. Now, this is very important on solving vector problem if you want to resolve. This particular vector, anytime you are doing vector, always go anti-clockwise. This particular vector, there is no vector here, you start from this point up. Don't start from here, always start from this. This is the origin, you start and go. Now, there is no particular vector here, so the net where we are going to meet a vector is this. So we are resolving for the horizontal component. It doesn't matter, you can resolve anyone first. We are using fx, you can resolve anyone first, does not matter. Resolving for the horizontal component, remember you use cos to resolve for the horizontal component. So we have fx is equal to f1 cos, what is the direction of this vector? Theta. So we have θ1 plus, if you are going this way, there is no particular force here. The next time, or the next place we have force is here. So we have F2 cos, what's the direction of F2? θ2. Now, but if you watch your Cartesian plane, cos is negative in this quadrant. Therefore, this will change to plus minus F2 cos θ2. Be very, very careful with that. Minus F2 cos θ2, because we are going to see that when we start solving questions. Plus F3. Now, will the F3 be positive or negative? If we watch the third quadrant, cos is negative, therefore we also have minus F3 cos θ3 plus F4, will it be negative or positive? If you want the fourth quadrant, cos is positive, therefore we still have positive F4 cos the direction, the one it makes with the horizontal, theta 4. So this is what you need to do. Always remember your negative sign, the base, the quadrants. Very, very important. Now if you are resolving for the vertical now, resolving for vertical component, we are using F1 to denote the vertical component. So what do? This time around we are making use of the sign. So we have Fy is equal to F1 sine theta 1, because anything here is positive, including sine, plus F2, sine is still positive, so we have F2 sine theta 2 plus F3 now falls here, and the sign is negative this side, so we have plus minus F3 sine theta 3 plus F4 here, the sign is also negative here, so we have minus F4 sine theta 4. Always know your Cartesian plane. This is very, very, very important if you want to be very good in solving this. So we are going to enter question now and see how to apply these formulas. So over to question. Now we have an example here. We are going to use this example to explain the formulas and how to apply them. And we have more than 2 vectors here. We have 1, 2, and 3. So what we are going to do now is to resolve these vectors into 2 components, the vertical and the horizontal components. So first, always go your clockwise. You start from here. I mean the anti-clockwise. Start from here. You go this way. So we don't have any force here. So the next thing we have here is this. Depends on what you are resolving for. If you want to resolve for the horizontal, you can say for horizontal component. That is f sub x. We have f sub x is equal to, here you use cos to resolve for horizontal component. So cos is positive here, so we have 10 cos 30 degrees plus, there is nothing here. Move over to this, we have 12 cos 40 degrees. But remember, cos is negative this side. So since cos is negative this side, we are going to put minus, as I explained. We are going to put minus, plus, nothing is here. We come to this, 15 cos 60 degrees. Always pick the angle that is making the angle the vector is making with the horizontal. Very, very important. Always pick the angle this vector is making with the horizontal. We are not putting a negative sign because at this point, cos is always positive this side. Okay. What we now have is we press our calculator. So 10 cos 30 degrees will give us 8.66. I will leave my answer to 2 decimal places. 8.66 minus 12 cos 40 will give us minus 12 cos 40 will give us minus 9.19 plus 15 cos 60 degrees. 15 cos 60 degrees will give us 7.5. So when we add this, we get our fx. We have 8.66 minus 9.19 plus 7.5. So that will give us 6.97 Newton. So when you resolve this particular question to the horizontal component. The horizontal component gives us 6.97 Newton. Always take note of the sign. If you don't put the signs, you end up getting the wrong result. So let's now resolve for the vertical. We are using sign to resolve for the vertical. So we have for the vertical component, which is f sub y, we have f sub y is equal to 10. But remember from our diagram, in our diagram we have nowhere sign is negative. So in the first place, sign is positive. We have sign 30 degrees plus where 12 falls is positive, so we have 12 sine 40 degrees. But where 15 falls is negative. Sine is always negative, so we have plus minus 15 sine 60 degrees. Always take note of your signs. Be very, very careful. So we have 10 sine 30 degrees will give us 5 plus 12 cos 40, 12 sine 40 degrees is 7.71 minus 15 sine 60 will give us plus 12.99. So when we add this, this will give us minus 12.99. So when we add this, we have 5 plus 7.71 minus 12.99. So this will give us minus 0.28 Newton. So this is what we have when we subtract this. Forget about the negative sign. It does not matter. It will not affect the answer to our question. So whether you are getting negative sign or not. Now we have resolved that particular diagram to a horizontal component and also what? A vertical component. Now we venture into solving the question now. Let's get the resultant. Okay. Now, solving now the resultant vector, that will give us, we have resolved to this now. Our diagram will now look like this. From the 3 vectors, we only have 2 now. Fy, f sub x is minus 0.28. Yf, y, this is 6.97. Fy is minus 0.28. So when we bring out our resultant force, which is F, here also becomes minus 0.28. So this is what we have. So our resultant now, we can now make use of what? Pythagoras theorem. Our resultant force becomes F squared is equal to squared plus Fy squared. So this gives us Fx is 6.97 all squared plus minus 0.28 squared. So this is where I say that the negative sign will not affect the answer, because anything negative squared will always give you what? Positive. So we have 6.97 squared will give us 48.5809 plus 0.28 squared, and that will give us 0.0784. When you add this, we have 48.5809. Then if you sum these two, our total force here becomes 48.6593. But we are not looking for f squared, we are looking for f. Therefore, f becomes square root of 48.6593. So this gives us, if you take the positive square root of that, square root of 48.6593. That gives us 6.98 Newton. This is the resultant force. So that is how to solve the question. Always take note of the signs. So the resultant force is 6.98 Newton. Now, if you now want to solve the direction, you can always use your tan. For the direction theta now, we have tan theta is equal to opposite, which is Fy over the adjacent, which is Fx. So that gives us tan theta to be Fy, we have calculated Fy to be minus 0.28 divided by Fx, which is 6.97. So this is what we have. If you divide this with your calculator, let me finish it this side. We have 0.28 divided by 6.97. So that will give us our tan theta to be minus 0.0402. Then the tan inverse of this becomes, the tan inverse becomes 2.30 degrees. 2.30 degrees. So that is how to solve the resultant vector and the direction, no matter what the question or how the question comes. This is how to solve it. If you have any problem here, please always comment. Go to the exercise section. You are going to see more questions concerning this. Also go through the past questions. You are going to see more questions concerning this.